For two parties to communicate, they need to agree on the message they exchange. If one party assumes messages are in Spanish, and the other assumes they're in Cambodian, they will not be able to communicate. For computers, this means agreeing on what fields messages have, how they are arranged and formatted, and how they are represented. To generate a message to send, software typically has to create a copy of it in memory, which it then passes to the networking card. Similarly, when a computer receives a message, the networking card puts that message in memory, which the software can then access. Understanding how this works and some of the pitfalls you can encounter is important if you want to understand network protocols and write network protocol software. So let's start with a simple model of computer memory. In most computers today, memory is organized in terms of bytes, 8-bit chunks of memory. A program has an address space starting at address 0. Most computers today are 64 bits. This means that memory addresses are 64 bits long, so a computer is up to 2 to the 64 bytes, or 18 sextillion bytes. In practice, computers today do not have this much memory. They have gigabytes, which is 2 to the 30th. In this example, our computer has 8 gigabytes of memory shown on the left, so its largest address is the hexadecimal value shown of 0x0200000000. Software can access each byte of this memory, or access byte in groups, such as loading a 64-bit integer from 8 contiguous byte cells of memory in a single instruction. But how does a computer represent a multi-byte value? Let's say we want to represent the number 1024, which in hexadecimal is 0x0400, or 4 times 256. This value requires 16 bits, or 2 bytes. Which byte comes first, 0x00 or 0x04? How you lay out a multi-byte value in memory is called Endianness, and there are two options. In Little Endian, the least significant byte is at the lowest address. So the least significant byte comes first in memory. It turns out that from a computational architectural standpoint, this can make the most sense. The other option is Big Endian, where the most significant byte is the lowest address. Big Endian makes more sense to a human reader reading left to right because it's how we write numbers with the most significant digits first.